Hello and welcome to part 3 of my GSA introduction tutorial video for uni students. Today we're going to be learning about constraints and loading. So here we have the beam from last time, the beam frame, going up, across and down with a particular cross section that we defined in the material grade and then the section library. So to apply restraints, you can do this one of two ways. So for starters, if you've got a very simple beam, a very simple frame, you're going to want to do it in this section. On your nodes, double click on nodes, you got where you input your nodes, you'll see nodes and restraints. If you click on restraints, you can apply your restraints for each individual node here. So we know that the two on the floor, so say we want to apply a incast restraint on node 1, and on the other one on the floor, we want to apply a pin constraint. So we want 0, 0, 0 and 5, 0, 0. So node 1, you can either put these in, so you can say yes to restrain in the X, Y, and Z. Singular values, they are your displacements. Double values are your rotations. So yeah, you can consider them to be, so can it move in the X direction? Can it move in the Y? Can it move in the Z? Can it rotate in the X, Y, Z? So that's what they all mean. So you can either input all of them manually, or you can, once again, right click, go down to your wizard, and then it will give you some examples of what you can apply as a restraint. So we want to apply a pin at 2, and that will automatically put all of the displacements as restrained, but leave all the rotations free. Click OK, and that's automatically done for us. So you can do it that way, or if you go to constraints, generalize restraints, this is much more useful if you have, say if you're building a very complex model and you have, say, a few dozen nodes that you want to restrain here. So stage list is not important just yet, but we just want to put that as all. So that's all stages of the analysis that we're going to be doing. So these restraints apply at every single step along the analysis road. Nodes. So here you can apply, say you want all your nodes to be restrained, you can do like that. If you want only node 1, 2, and 3 to be restrained, you can do like that. Or if you want node 1 to 4, which will be node 1, 2, 3, and 4. Oh, no. Oh, no, sorry. My mistake. 1, you have to actually type 2, 4. That will apply a restraint at node 1, 2, 3, and 4. So, yeah. And then from there, you can just apply, again, you can either wizard or apply the restraints here. And yeah, if you want to apply a certain restraint to multiple nodes at once, you want to do it through this method. If you want to apply individual restraints to individual unique nodes, just go to nodes and go to restraints. So for now, we're going to stick with this, but yeah, if you need it, it's here. If you want something a bit more robust. So anyway, just delete that, get it out of the way. Right, so loading. Very simple. Node loads. Nodes are one-dimensional functions, so they apply one-dimensional forces, so point forces. Beam loads, they are two-dimensional they have two-dimensional properties, and so you apply beam loads are uniformly distributed loads. So you can assume node load equals point load, beam load equals uniformly distributed load. 2D element load, pressure, 3D element load is, well, 3D pressure. So we don't want to worry about them just yet. So anyway, yeah, just before we get on with that, you've got these up here. So label your node outlines. So that just tells us where all the nodes exactly are. We click on label node IDs. That IDs each individual node for us. So if you get confused as to what node is exactly what, you just press that when you're in the view button. That's what these all are. These are all your view buttons for different angles. So if we click on the Y elevation, that gives us into the Y axis. So we know that this is node 1, 4, 3, and 2, because I applied it 1, 2, 3, 4. Label restraints. So click on that, it tells you what nodes are restrained. So we know at point 1 we applied a cast restraint, and at node 2 we applied a pin constraint. So they have shown up here. Label elements, so we know we got element 1, 2, and 3. Yeah, so same as nodes, elements. Each individual element is given a number ID, and that's just where it is in this list. Section shapes, so that just gives you an idea of the section that is going in the middle of that element. So obviously that looks how that would look normally. Element releases, and you don't have to worry about those last two for now. So yeah, applying your loads. So you want to apply a point load, go to node loads. What node? So we want to apply, say, a horizontal force in the x direction at node 4 to push the beam in this direction. So we go to node loads. We want at node 4, load case 1. We want to apply it on the global axis. We want it applied in the x direction, and say we want a 3 kilonewton force applied. So load cases are simply, well, I'll show you what they are. Beam loads. So beam loads are loads that you apply to a beam. So say we want to apply a sort of generalized gravity load on beam 2. So we want a downwards UDL force on beam 2. Go to beam loads. Beam 2, load case 1 again. We want it uniform on the global axis. We want it, just leave that as it is, direction. We want it in the Z because that's down for us. And we want it to be, say, -1. So that's -1 kilonewton per meter. So now if we go back to here and click on all load diagrams, we now have this point force applied in this direction and a UDL applied across this beam here. Okay, and yeah, that's how you apply your loads.